Welcome to Dr. Carmenatty's channel, where we analyze the strategies, the mindset, and the breakthroughs that define our future. We don't just watch the news, we master the forces driving it. Look around you. Everything that defines modern civilization, the electricity that lights your city, the water that flows to your home, the transport systems that move millions every hour, they all rely on an invisible bedrock of technology. We call this foundation operational technology, or OT. It's the industrial control system, the sensor array, the pump, the valve. OT runs the physical world. Now, a colossal force is colliding with this bedrock, artificial intelligence. AI promises unprecedented efficiency, unimaginable speed, and the power to optimize every aspect of our essential services. But here is the critical truth we must face today. Integration creates a point of impact. When you inject this kind of power into the operational systems we rely on for life itself, you risk everything. The promise of AI is matched only by the catastrophic potential of an unsecured implementation. We stand at a hinge point in history. This looming risk is not theoretical. This is a tangible, immediate danger. We are talking about cyber attackers using the speed of machine learning to disrupt power grids, poison water supplies, or halt entire transport networks. The enemy moves at the speed of light. We must move faster. Recently, the global authorities, including CISA and the NSA, jointly released a monumental document, The Principles for the Secure Integration of AI in Operational Technology. This document is not a recommendation, it is a roadmap to resilience. It is a survival guide for leaders, engineers, and decision-makers who hold our infrastructure in their hands. If you are unfamiliar with this domain, listen closely. This narrative provides the 4 pillars that determine whether AI becomes our most powerful servant or our ultimate saboteur. We move now from panic to power, from risk to control. Pillar 1, understanding AI. Master the tool. The first principle demands that organizations understand AI. Do not manage what you do not comprehend. Many leaders treat AI like a magical black box. You throw data in and solutions appear. This mindset is not just negligent, it's a recipe for disaster. Leaders must aggressively educate every layer of their team. They must move beyond buzzwords and truly grasp the inherent risks, the operational impacts, and the entire secure development lifecycle of the AI models they deploy. This comprehensive understanding dictates security. What does the model actually see? How did the data train the algorithm? Was the data set representative and trustworthy, or did it carry inherent biases and security vulnerabilities? Adversaries exploit these seams. They manipulate the training data, confuse the model with subtle adversarial inputs, and turn your optimization tool into a weapon against your own systems. This principle forces organizations to conduct rigorous internal training. Personnel must recognize these novel threats. Engineers must incorporate secure development practices from the very beginning of the project. Developers must ensure that the coding process prevents vulnerabilities. Leadership must champion a culture where curiosity about the AI's function is a required job function, not an optional interest. Only knowledge creates control. You cannot secure a system you do not understand. Organizations must break open that black box. They must illuminate its internal mechanisms and demand absolute clarity from every component. Commit right now to making a comprehensive understanding of the non-negotiable entry point for AI integration. Pillar 2, assess AI use in OT. calculate the impact. The second principle is a mandate for strategic rigor. Assess AI use in OT. Before implementation, leadership must define a clear business case for AI. Why are you introducing this complexity? Does the benefit, the enhanced decision-making, the cost-cutting, the efficiency boost truly outweigh the immense specific security risks the AI introduces to critical operational systems? If the answer is anything less than a resounding yes, you stop the project. This assessment is a multi-layered process. First, organizations must evaluate potential risks to their OT data. Operational technology environments generate continuous, high-value, time-sensitive data such as pressure readings, temperature logs, and flow rates. This data, the lifeblood of the system, becomes a prime target for attackers seeking to poison the AI model or gain deep insights into system vulnerabilities. Leaders must proactively manage these OT data security risks. Organizations establish strong data provenance, ensuring they know where the data originated and that unauthorized users did not tamper with it. Organizations segment this critical information from broader, less secure IT networks. This specific protection keeps the AI's intelligence sound. Next, the assessment must address both immediate and long-term integration challenges. The integration process itself presents a vulnerability window. Organizations must rigorously test the interface between the AI system and the physical controls. They establish a clear, documented path for how the AI affects the physical environment. No system goes live without aggressive, continuous stress testing. Remember, OT systems prioritize safety and availability above all else. A glitch in an IT system causes a crash. A glitch in an OT system causes a catastrophic failure, potentially threatening human life. Organizations must meticulously calculate the kinetic risk, the risk of physical harm, before they inject algorithmic power into essential services. We choose caution, calculation, and control. Leaders demand detailed, quantified risk reports before they authorize integration. This principle of rigorous assessment is where resilience begins its hard-fought battle against reckless innovation. Pillar 3. Establish AI governance. Forge the framework. The third principle is the engine of sustained success. Establish AI governance. Governance takes the theoretical structure and makes it an institutional reality. It demands structure, accountability, and continuous evaluation, making security an active, ongoing process rather than a one-time deployment task. Organizations must implement robust governance frameworks that clearly define roles, responsibilities, and decision-making authority over the AI systems. Who owns the risk? Who validates the outcomes? This framework ensures that a multidisciplinary team, cybersecurity experts, OT engineers, and legal compliance officers oversees the entire lifecycle of the AI solution. Continuous model testing becomes the operational standard. AI models are dynamic. They drift, they learn, and they change. They degrade over time as the environment shifts or as attackers probe their defenses. The governance framework mandates constant testing and validation to ensure the model remains accurate, reliable, and secure. Organizations must detect and correct model drift, the slow erosion of accuracy before the model translates into physical danger. Furthermore, compliance is non-negotiable. Operational technology is heavily regulated, often across multiple sectors: energy, water, transportation. The governance structure must ensure that every AI deployment complies with evolving regulations. The governance structure integrates AI security into existing organizational security and compliance processes, ensuring that AI security is not a standalone silo, but a core element of the overall risk management strategy. This principle shatters organizational silos. The principle forces IT security teams to collaborate seamlessly with OT engineers. The principle establishes a central authority that monitors the model's performance metrics and its adherence to ethical standards. When governance is strong, the system adapts, resists, and maintains its integrity even under pressure. Leadership enforces the framework, ensuring every single decision carries clear accountability. This commitment to structure transforms ambition into reliability. Pillar 4, embed safety and security, maintain the human control. The final principle crystallizes the path forward, embed safety and security. This mandate means making resilience an intrinsic part of the AI system's design and operation. We cannot just secure the walls, we must harden the core. Oversight is paramount. Organizations maintain constant vigilance over the AI system's actions. They ensure transparency in the AI's decision-making process whenever possible, providing clear audit trails for critical operations. When an AI agent recommends a change to a critical valve setting, the system must explain the logic and the data points that drove that recommendation. Transparency builds trust. Crucially, organizations must integrate AI failure into their existing incident response plans. When, not if, but when an attack, malfunction, or a model failure occurs, the response must be swift, deterministic, and effective. The plan must clearly define the process for isolating the AI, reverting to manual control, and ensuring system safety. This requires establishing human-in-the-loop mechanisms for all critical decisions. A human operator must retain the power to veto, override, and manually control the physical system, regardless of the AI's confidence level. The ultimate safeguard is the fail-safe mechanism. Organizations must engineer every OT system augmented by AIs to default to the safest possible state upon failure detection. If the AI system stops functioning, the plant does not spiral out of control. It reverts to a known, secure, and predictable state. This dedication to fail-safe design limits the consequences of the worst-case scenario. We are integrating AI into the very machinery of modern life. We must therefore design for a world in which we extract the maximum benefit while minimizing existential risk. These 4 principles: understand AI, assess use, establish governance, and embed safety, give us the power to achieve that balance. These principles transform reactive defense into proactive dominance. We face a time of unprecedented technological convergence. The choice is will we allow this power to overwhelm us? Or will we seize the moment, apply these principles with discipline, and forge a new era of secure, resilient critical infrastructure? The safety and reliability of our essential services, the very functioning of our society, depend on the action we take right now. Thank you for engaging with this critical intelligence. If this conversation about control, strategy, and power resonated with you, I urge you to share your comments below. Tell us which of these 4 principles you believe is the most difficult to implement. Like this video to amplify this message, and subscribe to Dr. Carmenatty's channel. We bring you the knowledge you need to master tomorrow's world today.